Hey guys, we are going to look at the informal idea of an inverse. Just what are the basics of it? So an inverse notation looks like this with f to the power of -1. When you see that, they're talking about the inverse of a function. The original function and its inverse are reflected over the equation y equals x right here. So they are a reflection over that line. We also know that when we do inverses, we are switching our x's and our y's. So if we look at example number 1, we have already gotten the graph of x squared, but we're only taking it from x greater than or equal to 0. So it's already graphed right here for us. So if we want to graph the inverse function, all you have to do is identify some points. So 0, 0, 1, 1, and 2, 4. Those are some ordered pairs. What you do for an inverse is you switch your x's and y's. So 0, 0 is not going to change because if you flip 0, 0, it's still just 0, 0. 1, 1 is also not going to change because switching the x's and y's on that, still 1, 1. But here at 2, 4, if I reverse the x's and the y's, if I switch those, that would be at 4, 2. And notice it is the same distance to that line on both sides. It's a reflection over that line. And then I can connect the dots and I can see that that's what the inverse function would look like. State the points of intersection. Well, those are 0, 0 and at 1, 1, just like you can see. They intersect each other right here. And the intersection is always going to be on that equation y equals x. That's where your points of intersection happen between your original function and your inverse function. Determine f of 2 and the inverse of f at 4. Well, f of 2 is pretty easy to find because I just have an equation. So if I want to find f of 2, this used to say f of x. So x is 2. So I just have to replace x with 2, and 2 squared is 4. So f of 2 is 4. This, remember your x's and your y's are switched. So what this is really saying is where is f of x equal to 4? So the x on the inverse is the y on the original. Well, we actually just did the opposite of this. But if we hadn't, we could work it out, where x squared, that's what f of x is equal to 4. If I take the square root of both sides, I get plus or minus 2. But remember, we're only using the positives. We're doing greater than or equal to 0. So my f of inverse 4 would be equal to the positive 2. Like I said, we already did it technically above, but that's how you would work it out. And this last one that we're going to look at together, we have F is Fahrenheit in degrees, C is the temperature in Celsius. The conversion from Celsius to degrees is given by this right here. A says determine 30 degrees Celsius in Fahrenheit. So that can go straight into the C. Easy enough. So Fahrenheit equals 1.8 times 30 plus 32. And then I can just put that in my calculator, and we get 86 degrees Fahrenheit. Next one says solve for C. What does this mean in relation to the situation? So if I take my F equals 1.8 C plus 32, if I solve for the C, I would subtract 32, so I'd have F minus 32 equals 1.8 C. And then I would divide everything by 1.8. So C equals F minus 32 divided by 1.8. And you can just leave it like that. Make sure you're dividing everything by 1.8. What this means in our situation is that if I have my Fahrenheit now, I could convert it to Celsius with just an easy substitution. Now you could go to this one and do the solving, but this already gets it ready to find my Celsius. So verify that the inverse at 86 equals 30. So that's where we would use this one right here. So this right here is my Fahrenheit. It's going to output a C of 30. So I put C equals 86 minus 32 divided by 1.8. And then you can put it in your calculator and it should come back out as 30 degrees Celsius.